So the first set of directions for 4, 5, we're going to graph some sine graphs first, and then we're going to go to cosine graphs. The first set of directions, and let's write down this equation. This is going to help us. Let's write y is equal to big A sine big B times x. And I'll break this up and kind of show you which each part is equal to. The absolute value of A, we're going to call the amplitude of our graph. You may have heard of the word amplitude when you're graphing. Amplitude is the distance, it's a positive distance of how high the graph goes or how low the graph goes, and we'll show you what an amplitude is once we actually get to your graph. 2 pi divided by your B value is equal to the period of your graph. A sine graph cycles through different types of periods based on what's in the equation of the sine graph. And this is so completely new to you. I don't think you've ever done anything like this, so I'll try to break it down as easy as I can from the very beginning. Alright, so y equals big A times sine of B times x. X is like your angle, and B will be the coefficient of your angle. The little x actually represents what your angle is, and there'll be some number being multiplied times your x. That number's the B value. Then there'll be some number out in front being multiplied times your sine, and that's your A value. So the first set of directions, so we need to know all that. The first set of directions say determine the amplitude. And I'm going to abbreviate here. I'm going to abbreviate it as amp. Determine the amplitude, and then it says period, and then it says graph the function and y equals sine of x. Graph the function and y equal sine of x for 0 is less than x and x is less than 2 pi. Alright. Determine the amplitude, period. Graph the function y equals sine of x. Graph the function and graph y equals sine of x. That's an and symbol. And y equals sine of x for x, which is your angle. X is between 0 and 2 pi. Alright, so you have no idea what we're doing here, but I'm going to have to flip to the next screen so I have enough room. So number 2, anybody still writing? Got it? Alright, so number 2 gives you this equation. Y is equal to 5 sine of x. Alright, so the first thing they want to know is they want to know what the amplitude is of this sine graph. That's the distance of how high it's going to go and how low it's going to go from the x-axis. So that's pretty easy to find. Amplitude is the absolute value of the number out in front. It's the number being multiplied times your sine. You can probably do that in your head. So the absolute value of 5 would be 5. So they want to know what the amplitude is. Then they want you to graph y equals sine of x. They want you to graph y equals sine of x. And they want you to graph y equals 5 times sine of x on an x and a y axis. Alright, so right now, all you know how to do is to make a t-chart. As far as graphing, I'm going to show you some shortcuts. I'm going to show you how to use the t-charts. And then we're going to get rid of the t-charts because we're going to know what a sine graph looks like, and we're going to be able to graph these without t-charts. It tells us that we're going to graph from 0 to 2 pi. It tells us we're going to graph from 0 to 2 pi. That was in the directions. So that's what I'm going to pick for my x's. Alright? And I'm going to go in increments of 90 degrees. So I'm going to do 0, and then I'm going to do pi over 2, then I'm going to do pi, then I'm going to do 3 pi over 2, and then I'm going to do 2 pi. The directions tell me to graph one period of my function, and it says I'm going to graph from x is 0 to all the way where x is 2 pi. So we're going to use our unit circle. We know when we're looking for the sine of an angle, what are we looking for, the x or the y? The y. So at 0 radians, what's the y value at 0 radians? 0. So when x is 0 radians, if we plug that back into the equation, that's sine of 0 radians, that's 0. At pi over 2, what's the sine value at pi over 2? 1. What's the sine value at pi? 0. What's the sine value at 3 pi over 2? Negative 1. What's the sine value at 2 pi? 0. Alright. Any questions about where I'm getting those numbers from? This is kind of awkward because we're actually going from the unit circle and we're taking those values and we're putting them in an XY chart so we can graph the function on an X and a Y axis. Okay? We're going to do the same thing for y equals 5 sine of x. We're going to make a t-chart. We're going to pick the same x's because that's what it told us to do in the directions. We're going to go from 0 to 2 pi. We're going to count by pi over 2 so we have several points. I'm going to use the same x's here. So we can cheat a little bit because we've already found the sine values in the first t-chart, except this time once we find the sine at 0 radians and we get that number, then we have to multiply it by 5. So the sine at 0 radians was 0, and 5 times 0 is 0. So that's all that the 5 is going to do, is once you find the sine value, then you're going to multiply it by 5. Sine of pi over 2 is 1. 5 times 1 is 5. Sine at pi is 0. 5 times 0 is 0. Sine at 3 pi over 2 is negative 1. 5 times negative 1 is negative 5. Sine at 2 pi is 0. 5 times 0 is 0. So we're going to make two little t-charts, and then we're going to actually graph. They're asking us to graph both graphs. So we're going to make an x and a y axis. Our x values are going from 0 to 2 pi. So what I do is I go all the way out and I do a 2 pi, and then I eyeball where half of that is to kind of get me a pretty decent graph here. I don't really suggest that you use graph paper. So I go halfway there. That would be how many radians? Pi. And then I do half of the little halves. So I eyeball where a half would go here, and I eyeball where a half would go there. The first dash would be pi over 2, and the third dash would be 3 pi over 2. So you are going to sketch this out just on your notebook paper. So you do want to get it as evenly spaced out so your graph actually looks halfway decent. Now the first graph, y equals sine of x, it has an amplitude of what? It didn't ask you for the amplitude of y equals sine of x, but what would the amplitude be?
1.
It would be an understood 1. So I know I've got to go to 1. Got to go to 1. Up and down 1, and then when I graph the other graph, I got to go all the way up to 5. 1, 2, 3, 4, 5, and I've got to go all the way down to 5. 1, 2, 3, 4, 5. I'm going to graph the first graph in yellow. I'm going to graph it in yellow. So when we're at 0 radians, when our x is 0, our y is 0. So that would be a point right there. At pi over 2, when I go to the right pi over 2, I go up to 1. At pi, my y value is 0. At 3 pi over 2, my y value is negative 1. And at 2 pi, my y value is 0. So if I connect those points, I have just a little piece of the sine graph. Sine and cosine graphs are continuous. They go on forever and ever and ever and ever. But they're just asking me to graph a little section of it. Okay, let's graph y equals 5 sine of x. And we're going to start to use some of those transformations that we used in Algebra 2 to make our lives easier. So I'm going to graph y equals sine of x in green. And when x is 0, y is 0. When x is pi over 2, y is 5. When x is pi, y is 0. When x is 3 pi over 2, y is negative 5. And when x is 2 pi, y is 0. So it's going to look the same. Y equals 5 sine of x is going to look the same, except the amplitude is 5 times as big. It's just like a vertical stretch. How many of y'all remember us doing vertical stretch, vertical shrink, horizontal stretch, and horizontal shrink? That's what that 5 actually does. So right now I'm showing you the t-charts, and I want to get rid of the t-charts just as quick as I can because we don't want to make those t-charts. Okay, we don't want to make them. We want to know what a sine graph looks like. And what a sine graph looks like, it is always starts on the x-axis. Sine always starts at the x-axis because at 0 radians, your sine value is always 0. So you start on the x. It goes up as long as your a is positive. So it's going to go up, go back to the x-axis, going to go down, and go back to the x-axis. If the a value is negative, it's not going to go up first, it's going to go down first because that negative would be a reflection over the x-axis. Okay? So just to show you why this graph looks like it does, that's why we're using a t-chart. Alright? Now I'm not going to make a t-chart for the next one, and we're going to see if we can do the next one. The next one that I have picked is number 4. Let's look at number 4. Same directions. So it says y is equal to 1/4 sine of x. It wants to know the amplitude. So let me go back to that previous one. So do y'all get the amplitude here? The amplitude is how high the graph is from the x-axis, or even how low it is. So the amplitude is 5 if you go to the highest point from the x-axis, or if you go to the lowest point from the x-axis, and we're talking about distance, which is always positive, then if you go down here to the lowest point, that's also 5 units. So an amplitude tells you how high and how low the graph goes from the x-axis, and amplitude is always positive. Alright, so what's the amplitude of this graph? Of this equation? 1/4. So it's going to be a short little graph, right? It's the absolute value of 1/4. If that number's negative, you always make it positive. I'm just going to show you in your notes. Amplitude's always positive. Alright, they're asking us to graph y equals sine of x, and they're also asking us to graph y equals 1/4 sine of x. So we're going to do, without t-charts here, we're going to draw our y-axis and our x-axis. The directions still say go from 0 to 2 pi, so I'm going to go all the way out to 2 pi. I'm going to make me some little even dash marks. I'm going to go in the middle and do pi. I'm going to go halfway and do pi over 2. Halfway between pi and 2 pi is 3 pi over 2. Alright, so the amplitude of y equals 1/4 sine of x is 1/4. The amplitude of y equals sine of x is an understood 1. So that tells me how I need to mark my y-axis. So I don't know how you want to do this, but I might do 1, 2, 3, 4, 1. So I can do a 1/4 there. So I'm scaling my y-axis by 1/4. And then I'm going to go down 1, 2, 3, 4, 1. And make that a -1. I'm going to graph y equals sine of x in yellow because it's asking me right here to graph both of them. So y equals sine of x. When your angle is 0 radians, what's your sine value? 0. So we're always going to start at 0, 0. And then if we're graphing just y equals sine of x, the amplitude of y equals sine of x is 1. So at pi over 2, I go up to 1. At pi, I go back to the x-axis. At 3 pi over 2, I go down to 1. And at pi over 2, I go back to the x-axis. So in this set of directions, they're asking you to graph sine, and they're asking you to graph 1/4 sine. So we're going to graph y equals 1/4 sine of x with green. And when x is 0 radians, the sine at 0 radians is still 0, 0. So you still start at 0, 0. But at pi over 2, you're only going up 1/4 of a unit because that's your amplitude. So at pi over 2, you're only going up 1/4. At pi, you're back at 0. At 3 pi over 2, you're going down 1/4. And at 2 pi, you're back at 0. So this is an example of not a vertical stretch, but our green graph is a vertical shrink. And that's because our a value is a fraction. It's actually shrinking the value there. And again, these graphs are they are continuous, but they don't want us to graph something that's continuous because we couldn't do that because it runs forever and ever and ever. Alright. So let me do one more, and I'm going to shorten your homework assignment because we are not going to finish these notes. Let's do one more example. Let's do number 6. And you're doing y equals -4 sine of x. We're underneath the same set of directions. Maybe. Let me look. Yep, same set of directions. What's the amplitude of y equals -4 sine of x? Okay, the amplitude is the absolute value of your a, so the amplitude is +4 because that's distance. Okay, what the -4 is going to tell us is our graph's not going to go up to 4 at the first point, or the second point it's going to go down. So we got to still graph both of these graphs. They're trying to get you to understand what you're doing. Make your x and your y axis. Gonna graph y equals sine of x real quick in yellow. Need to mark my y-axis. How am I going to do that? How far do I need to go up and down on the y-axis? 4 units. 1, 2, 3, 4. It's as high as I have to go. 1, 2, 3, 4 is as low as I have to go. So for y equals sine of x in yellow, it's going to look like this. This is the third time we've graphed it. So there's your original graph. Again, this is leaning towards the concept of transformations. We're taking that graph. The negative means we're going to flip it over the x-axis. We're going to reflect it over the x-axis, and we're going to stretch all the y values by 4. So instead of going up 4 on that second point, we're going to go down 4. And again, you can make a T-chart for this. I just would rather show you the transformations because they're quicker. So the graph's going to start at 0, 0, then it's going to go down to 4, go back to the x-axis, go up to 4, back to the x-axis, and then you'll sketch that one in. Alright, so we are way short of finishing our notes. Y'all are only going to be able to do, oh, you're going to love this, number 1, number 3, and number 5. If y'all will just do those first 3, we'll try to make it up tomorrow and see where we get. Okay? Homework is on page 533. I'm way far behind because we finished it. I gave you more time to finish the quiz. So y'all just do number 1, number 3, and number 5, and we'll pick back up tomorrow.